Now we will consider the phase shift keying or PSK. This phase shift keying is the counterpart of phase modulation in analog domain. So here in this case, the phase of the sinusoidal carrier will be varied according to the binary baseband signal. So if we assume that logic 1 will be represented by, say, 0 phase, then logic 0 will be represented by a phase of pi. So whenever we have logic 1 symbol, the sinusoidal carrier will immediately come to the 0 phase condition, and whenever we receive 0, we have 0, logic 0, the sinusoidal carrier immediately go to the pi phase, that is 180 degree out of phase. So the PSK signal can be represented as, keeping in mind that there is no change in the amplitude. So if amplitude is, say, AC, then for logic 1 it will be represented by simply cos omega ct, and AC cos omega ct plus pi for logic 0. That means this one is equivalent to or minus AC cos omega ct for logic 0. This is how we can represent the PSK signal. So let us now see its waveform. So as usual, we will take a simple data, say 1 0 1 1 0. Let us divide this data this time into several time slots, each of with TB. So this is the carrier. Carrier is a sinusoidal variation, so you can draw it in this way. Simple sinusoidal carrier. Now the PSK signal. For PSK signal, the amplitude will remain the same. So this one is AC, this one is minus AC, this one is 0. The first bit is 1. 1 is represented by AC cos omega ct, though we have drawn it as sin omega ct, same thing. So instead of cos omega ct, we can write in equivalent fashion, we can write AC sin omega ct. So there will be no change in this carrier. Amplitude remains same. Next bit is 0. 0 will be represented by the phase of pi, that means minus AC cos omega ct. So instead of starting from the positive polarity, it will start from the negative polarity, like this. Next bit is 1, so it will immediately change to 0 phase. So again it will start in this way. Next bit is 1, means 0 phase, so it will continue. This one is 0, so it will start from pi phase. There should not be any change in time period, but as you can see that because of the problem of drawing, I have changed little bit change in the time period. But actually there should not be any time period, that and there should not be any change in amplitude as well. The only change is in the phase. Whenever there is some change in the logic state, we have some phase change, and that phase change is abrupt just at the time of transition. So this is the waveform for the PSK signal. Well, the PSK waveform was the transmission of PSK, unlike ASK. PSK transmission is polar in nature, otherwise it is almost identical to that of the ASK, particularly the spectrum. So power spectral density of PSK is almost identical to that of ASK. But there is no spike here. That's the difference between ASK and PSK. Though the power spectral density appears to be almost identical, this is one-sided power spectral density. I have not drawn the other side. Though this similarity, but there is some dissimilarity as well, because the performance, particularly the noise performance of PSK, is much better compared to that of the ASK. Now the generation of PSK is almost identical to that of the ASK. So here we have product modulator again. So we have some carrier at one input. Here we have the other input, we have binary data, but the condition is in polar form. So if it is unipolar form, we will get ASK. If it is polar form, then we will get the PSK. So this is how we can generate the PSK signal. Now any signal may be detected, they should be detected in two different ways. One is the synchronous method, another is the asynchronous method. Unfortunately, PSK cannot be detected with in asynchronous fashion. So PSK cannot be detected non-coherently in non-coherent technique. So PSK can be detected only with coherent technique. So PSK signal, first we need a locally generated carrier, then we have integrator, then we have some kind of sampler and comparator. Comparator will compare with the threshold voltage and we will get binary output. So here we need a phase synchronization for the carrier and bit synchronization for these two. Or even we can eliminate this one also. So this one, this output may come to the comparator and we will get the binary output in a continuous fashion. But this one requires the bit synchronization and this one requires phase synchronization, and that makes this PSK detection costlier, because it cannot be detected with non-coherent fashion. And non-coherent technique means it is cheaper, but coherent technique means it is costlier. So PSK detection is costlier compared to the equivalent ASK. Binary PSK has a bandwidth of nearly 2 times of the, it is 2 by TB, 2 times of the bit rate. But the most advantageous part of this PSK system is its noise immunity, and it has got the best noise immunity among all the digital modulation scheme. So its minimum bit error probability compared to any other kind of modulation.